To AGT STEM. My name is Cashton. Let's get to the video.
Metal than you might expect. I should say element perhaps than metal.
So first thing I need to do is light the Bunsen. So there we are. Okay, and then what we've got inside the boiling tube is actually potassium permanganate.
It is one of the transition metals, and the row of transition metals stretches all the way from scandium over here to zinc over there. What makes manganese particularly interesting is that it is in the middle of this transition group. There are 10 transition metals from scandium to zinc, and manganese is number 5. The reason they're 10 is because each of them has a certain number of d electrons, 1 for scandium, 10 for zinc. So manganese in the middle has 5, and 5, if you're a mathematician, you will know is half 10. So it has exactly half the number of d electrons that can be accommodated in the shell.
All I've gone and done is just popped a couple of spatulas of potassium permanganate into the boiling tube, and as you can see from the colour, it's a very, very dark, almost black, possibly a dark green. So that's in there.
But let's begin just having a look at the metal itself. This is a bottle of manganese that Neil has lent us, and Brady promised that we wouldn't break it. And don't tell anyone, but I dropped it and a bit has fallen out at the bottom.
Look, you broke it. You broke it. Neil's going to be very angry at you.
Anyway, let's look at the metal. So you can see the metal is, in this particular form, it's come in sheets, but has this rather bobbly feature on the surface. This is the top of where the metal was done, and it's been broken up. What is also interesting, that I've got a magnet here, and you can see it's not magnetic at all, and you can't pick it up. Now you can ask, why is it interesting if something's not magnetic? Lots of things are not magnetic, and the reason that's interesting is if you look at its salts. So this is a salt of manganese. The label is not very good, but it's manganese sulfate, MnSO4. The first thing that you notice is that it is almost white. It's very slightly pink. And this is surprising because, especially in your first chemistry lessons, they say the characteristic of the salt of transition metals is that they're coloured. And here's manganese sulfate, almost white. Remember that manganese metal is not magnetic. Let's take the same magnet into the sulfate, push it down. So you can see that the salt sticks to the magnet. Now, I think that's extraordinary. Normally, you don't expect salts to be magnetic, and it's even more surprising if the metal is not magnetic, but the salt is.
Off the safety flame into the hot blue flame, get it so that it's at the tip of the flame, it's nice and hot there. Ah, you see that movement there? Perfect. That movement there, oh, you can see it going right the way up the tube, and now it's dropping back down again. And what's happened there, in the heat, we've changed the oxidation state of the manganese to +6, so it's now K2MnO4. You're also getting oxygen, which is why you saw that movement of the powder as the gas is being liberated, it shot up the tube, and you're getting manganese dioxide there.
And the reason why the salt is magnetic is because it has 5 electrons, these 5 electrons in the D shell, and they're so-called unpaired. They're each in a different volume of space around the atom. So each of them has a strong magnetic effect, and with all 5 of them, it's really magnetic. And the fact that the material has no colour is also associated with these 5 electrons. If you drop a solution of manganese sulfate, which is also colourless, into sodium hydroxide solution, you get a precipitate of hydroxide, and because there is air dissolved in the sodium hydroxide, the oxygen removes one of the electrons from the manganese, so it now is so-called manganese 3, which has only 4 electrons, and it's nice brown colour. So you suddenly get this colour change. This was one of the first experiments I did in my second year at university in a practical class. They didn't tell us what was happening, we had to explain it.
And so now we need to make sure all of it is being converted to +6 oxidation state. So I'm going to make sure it stays in that flame for just that bit longer.
The really famous compound of manganese is potassium permanganate, which is a purple colour. Potassium permanganate is KMnO4. In fact, in the MnO4 minus, the permanganate ion, manganese has no d electrons at all. They've all gone to the oxygen. And this very bright colour is because the light makes one of the electrons jump back to the manganese. So you get this very intense colour, which is very bright. Even a small amount of the material causes a lot of colour. And if you drop just a few tiny crystals of permanganate into water, you can see this beautiful purple colour spreading out. I persuaded Sam to repeat one of the earliest experiments I did myself after reading about it in a book, heating potassium permanganate.
And so apart from that movement of the powder up and down the tube, it doesn't look like anything else is really happening.
I did this when I was 14 or 15. Sam is using a nice boiling tube. I used a metal spoon and a gas stove.
We're going to put it into this sintered funnel that's sat atop of the conical flask, and then I'm going to add some concentrated alkaline to it.
And when you heat the permanganate up, there is a sort of small puff of gas, but nothing very exciting. But then you make so-called potassium manganate, K2MnO4, which is bright green if you put it in alkali solution. So Sam, if she's done what I suggested, has poured the solid out into a filter and then poured over it some strong alkali, and you should see this really nice dark green colour solution coming through.
And you can see there, normally if you put potassium manganate in solution, i.e. just in water, it would go a nice purple colour, but here, because you've got K2MnO4, it's actually giving you a lovely green colour.
But it's not a very stable compound. And if you add acid to the solution, it decomposes very quickly. And so you get permanganate back again, plus a precipitate, which you may or may not be able to see, of manganese dioxide, which is a brown solid. Now, when I did this experiment as a schoolboy in the kitchen, I didn't know all of this chemistry. And my sister's clothes were on the draining board of the sink. They were being washed. And I'm ashamed to say, and I didn't notice, that some of the permanganate or manganate got onto my sister's clothes and brown spots appeared all over it. And I was not very popular with my parents.
What, were you punished?
I can't remember. I think I was forgiven in the interests of science.
Thanks for watching. We'll see you next time.